Last night, the universe whispered a secret it was never meant to share. In the vast, silent gulf beyond Neptune, something extraordinary happened, something that shouldn't be possible. The interstellar traveler known as 3I Atlas, already a cosmic anomaly that defied prediction for years, suddenly divided. But this wasn't an ordinary fragmentation, not the kind we see when fragile comets crumble under sunlight or when asteroids break, apart from stress. This was different. It was deliberate, controlled, almost alive. When news broke that Atlas had split, astronomers expected the usual pattern: loss of energy, fading brightness, and scattered debris fading into the dark. But instead, telescopes across the world reported the opposite. Both halves burned brighter than ever before, as though the act of division had fed them rather than weakened them. In seconds, what should have been a cosmic death became an impossible rebirth. At first, researchers believed it was a sensor error, a reflection, perhaps, or a lensing illusion caused by background stars. But the data came from multiple sources, each confirming the same impossible truth. Atlas didn't just survive the split, it evolved from it, and that's what has the world's greatest observatories on edge tonight. Because if something from beyond our solar system can grow stronger by breaking apart, then we're witnessing a process that no physics textbook can explain. It's as if the universe itself just changed the rules, and no one knows why. When scientists examined the light signature, they noticed something chilling. Both fragments pulsed in perfect synchronization, their energy rising and falling in unison, like two hearts beating in the same rhythm across millions of kilometers. Normally, fragments spin unpredictably, tumbling through space in chaos. But these two moved as though connected, locked in formation, mirroring one another, with mechanical precision. Some astronomers called it a coincidence, others called it coordination. But the truth is, no one has ever seen anything like it. Even more unsettling was the velocity. Instead of slowing after separation, the fragments accelerated, defying every conservation law known to science. There was no visible thrust, no outgassing, no detectable reason. Yet both bodies surged forward as if powered by something deep within. Think about that for a moment, a cosmic object from another star system, splitting in two, each half suddenly brighter, faster, and perfectly synchronized. This isn't natural behavior. It's calculated, and that's why the scientific community isn't just curious, they're alarmed. Atlas was already a riddle when it first entered our system. It ignored gravity the way a magician ignores logic, disappearing from telescopes, then reappearing miles off its projected course, as if space itself were bending around it. But this new event, this duplication, takes the mystery to a level that borders on the impossible, because if an object from deep space can divide and gain power, what's to stop it from doing it again? Since that moment, every major observatory, from NASA's deep space network to Japan's Subaru telescope, has turned its focus toward the fragments of 3I Atlas. Data streams flood in every hour, but instead of answers, they only deepen the confusion. Orbital models collapse within minutes. Predictive algorithms fail to track their trajectory for more than a few rotations. It's as if the fragments refuse to be understood, changing behavior the instant someone tries to define them. Scientists are calling it a paradox in motion, because by every known law of physics, the fragments should have slowed, scattered, and dimmed. Instead, they remain locked in a synchronized orbit around a point that doesn't exist, a gravitational center with no measurable mass. It's like watching two planets dance around an invisible partner. Some researchers suggest it could be the result of an undiscovered force, a pocket of dark energy, or an electromagnetic resonance created during the split. Others whisper about something more extraordinary, the idea that 3I Atlas isn't a random rock at all, but a construct, a vessel, a mechanism designed for endurance across the emptiness between stars. Of course, most scientists dismiss that theory. They prefer natural explanations, an outburst of trapped energy, a structural fracture releasing internal pressure, maybe even a resonance caused by the object's rotation. But none of these ideas explain the synchronization, the acceleration, or the increase in luminosity. Each explanation solves one piece of the puzzle while breaking three others, and that's what makes this event so terrifying. Because the deeper researchers look, the less the universe seems to obey its own rules. Imagine two fragments racing through the dark, each glowing with impossible energy, bending light as though wrapped in their own gravitational field. In some telescope footage, faint distortions ripple around them, space warping ever so slightly at their edges. Not enough to cause alarm, but enough to remind us that we might be staring at forces far beyond our comprehension. If this were simply a comet, it would eventually crumble into dust. But Atlas refuses to fade. Its energy output has increased nearly 40% since the split, and its direction has shifted slightly, not away from us, but toward the inner solar system. That's why the tone in mission briefings has changed from curiosity to concern. Because if its acceleration continues, Atlas, or its fragments, could enter the orbital neighborhood of the terrestrial planets within months. No one is suggesting a collision, not yet. But the truth is unsettling. No one can predict what happens next. The fragments could vanish, reappear elsewhere or divide again, doubling their number and complexity. If that happens, tracking them will become impossible. And maybe that's the point. Maybe this isn't a decay, it's a replication. A process. A cycle we're only now witnessing for the first time. Because when an object breaks the laws of nature and grows stronger in the process, the real question isn't what it is, it's what it's becoming.